Hi guys. So in this video, we're going to solve this tree question. So let's see. Given a binary search tree, you need to compute the length of the diameter of the tree. The diameter of a binary search tree is the length of the longest path between any two nodes in the tree. This path may or may not pass through the root. So for the one that I'm going to show you how to solve, I want it to pass through the root. This is the root. Each of these are called nodes, and this is a leaf. So the longest path, if you look at this, is 1, 2, 3, 4, 5, 6. And if this wasn't there, then you just count that or from here. So what I did already is that I already wrote the code to create the tree. So I can show you that. We're not really going to go over that. But here's the code that I wrote to go over the tree. So that's not the point of this. So we're going to use my code and we're going to create this binary search tree. And then we're going to write our function here that will give us the diameter of the tree that we're looking for. So this is how the tree is going to look like that we're going to use. So let's see how it works. So right now, if there's three functions that I made available: print, insert, well, print and just insert, by the way. So let's insert 20 and 10 and 30. Let's see what that will look like. 20, 10, and 30. So if we insert 20, 10, and 30, we should have 20 as the root, 10 to the left, and 30 to the right, because it's a BST. So let's see. So I'm going to make this bigger, and then I will run the code, the node, because we're using Node.js. Node code. And diameter is undefined right now. That's because we haven't actually put anything here. But as you can see, the root is 20. As we said, that was the first number. To the left of the node, we have 10. And to the right of the node, we have 30. As you can see that. So this works. So the code that I wrote here works. So let's add more. 5, 15, 45. 5, 15, 45. 5, 15, and 45. And then the next one is 3, 7, 35. 3, 7, 35. And the last 3 is 8, 40, 43. 8, 40, 43. Wait, okay, just make sure. 8, 40, and 43. All right, so let's see that we have this tree. There we go, 20, 10, and to the left of 10 we have 5, and to the right of 10 we have 15. Left of 10 we have 5, to the right of 10 we have 15, right there. To the right of 30 we should have 45. The right of 30 we have 45. Beautiful, so it works. So now let's calculate the diameter of this tree. Diameter should be 6. 1, 2, 3, 4, 5, 6 going through the root. Okay, so we're gonna put our code here. So we're gonna pass in the root. Here is where I call, here's my constructor. Here we go, object. I'm gonna pass in the root to the function that we're gonna write. Okay, so let's do that. So to start, what I like to do is I like to create functions called helper functions. I use that a lot in my code, in most of my videos. And then what we can do now is, this is going to return some form of value. We don't know what that value is. But if we were to call that value, let's give it a value of S, whatever, or D. And then we can call it helper, and then we're passing the root. And then that D is what we return. There we go. So now we just need to fill in the helper function. So the first thing we want to do is we want to find out if the root is undefined. You always want to do that. If the root equals undefined, or we want to see if the root is null. If the root is null. If that happens, we return 0. So let's test this. But let's see, we can let's comment this out. So there's nothing here now. So we're not going to get any value because there's no value in the tree. So let's print this code out and see what we get. Let's clear this. 0. Beautiful. That works. Why? Because the root is undefined or null. So we get 0, as we should. That's the code. So the next thing is let's put something inside now. Let's not put back our values. So let's put something inside. So let's get the left value. Say helper. This is a recursive solution, by the way. I'm sure you can solve it without using recursion, but that's the first solution that comes to mind. Left, and then get the right value of the tree. There we go. So we have left and right. Now, this is going to give us 1. This will also give us 1. But actually, no, it wouldn't. What am I talking about? We can get the... Okay, so over here, the right side might be longer than the left side. What we want is the maximum. Which one has most? Either the right or whether the left of this root. Or if you take this one, either the left or either the right. If you take this one, either the right or either the left. So we want to know which one is the most. So we can use a math function, max, and then left, right. Find out the 2, and that will tell us. And so what happens is it always leaves out the root. So we add 1. And then this, and that's it. I believe so. This should work. And this will give us the diameter. So let's see. So diameter is 6 in this case. 1, 2, 3, 4, 5, 6. 6. There we go. That's it. Diameter 6. So if we want, we can let's see, 1, 2, 3, 4. Let's create a different tree. Let's put in a few numbers. Let's see. Let's erase all of this. Stop at 5. 12, 10, 35. If we do 12, 10, 35, so this would be gone. This would be gone. All of this would be gone. 12. It will look like that. So the root should be 3. 1, 2, 3. Let's see. Let me make sure I have 12. Okay, beautiful. Let's see. 3, as we expected. All right, guys. Thank you.